average rate of change, and estimating derivatives. Estimate the slope of the graph at the following points. So first we're going to estimate the slope at x1 and y1, and luckily it gives us these tangent lines here. So what we need to do is we need to find the slope of the tangent line. Notice that crosses a point right here and right here. So we have a rise over run, a slope of 2/3. You'll see the same thing with x2 and y2. We have a point right here and a point right here. You can barely see it, it is there. We get a slope of -2/5. So one way you can estimate tangent lines, or estimate the slope of a graph at any point, is by, let's say, the point right here, is by drawing a tangent line and then seeing what the slope of that tangent line is. So this one looks like the slope is 1. So that's one way. You may also have a table. So an airplane's position from the airport control tower is given. The plane is traveling due west from the airport. What is the average rate of change of the position of the airplane from t equals 0 to t equals 6 minutes? So we're going to use the average rate of change equation I showed you in the last video. F of b minus f of a over b minus a, where your first number is your a and the second number is your b. So you have f of 6 minus f of 0 over 6 minus 0. And the table just gives us those values. So for 6 it's 12.012. And then for 0 it's just 0 over 6 minus 0 is 6. And this is a minus 0, so it doesn't matter. 12.012 divided by 6 is 2.002. So that's the average rate of change from 0 to 6 minutes. And this one's asking us to find an approximation of the instantaneous rate of change of the airplane at t equals 3.5 minutes. If you look for 3.5 on the table, you notice it's between 3 and 4. So to estimate the instantaneous rate of change at 3.5, we can try to find the average rate of change from 3 to 4. So do that by f of 4 minus f of 3 over 4 minus 3. The values in the table, you have 7.312 minus 5.125 over 1, which comes out to be 2.817. This 2.817, we don't know this the actual value of the instantaneous rate of change, but that's our approximation since we're given 3 and 4. I have another table where you're supposed to estimate the value of f prime of 6 3 different ways. So remember, the f prime of something just means the instantaneous rate of change at 6, or the slope at 6. We can do this 3 different ways because we have 6 in the table. So one way you could go about doing this is using both 5.99 and 6, since they're really close to each other. So if we do that, f of 6 minus f of 5.99 over 6 minus 5.99, you get 3 minus 2.5 over 0.01. That's going to give you a slope of 50. Now another way you could do it is by using 6 and 6.05. Just plug those values in. If you compute that, you're going to get a slope of 2. Now another way is by using the values around 6, so 5.99 and 6.05. And plug those values in as well. I think that will give you a slope of 10. So let's have these values really close to 6. We evaluated it 3 different ways. Yeah, we got wildly different answers. We got 50, 2, and 10. And that's really all the information we can get because it's a table and not a graph, so we can't really see the actual function. All they're giving us is a table. So keep in mind that if you're ever evaluating a derivative from a graph, you're doing it like this. Make sure you try to evaluate it different ways to try to see if these answers are at least close to each other. Because if they're not, then there may not be a right answer. Like this function may not be differentiable at x equals 6. There may not be a slope. We're going to talk more about differentiability in an upcoming video, so keep that in mind. Alright, hot water is dripping through a coffee maker, filling a cup with coffee. The amount of coffee in the cup in ounces at time t, t is between 0 and 6, is modeled by a differentiable function 15 minus 15e to the power of negative 0.35t, where t is in minutes. Find the average rate of change of the amount of coffee in the cup between 0 and 6. So you're going to need a calculator for this one because you're not doing this in your head, really. F of 6 minus f of 0 over 6 minus 0. If you plug in 6 into this equation right here, you're going to get a value of about 13.1632. Plug in 0, you're going to get 0. That's over 6. Put that into the calculator as well. You're going to get about 2.1939. That's about the average rate of change between 0 and 6.